All right, let's get right into it. If you're a STEM student, I bet you know this feeling all too well. Those long nights, the endless problem sets, that sinking feeling when you realize you've poured hours into your books only for it all to just vanish when you actually need it. It is so frustrating, right? But what if I told you the problem isn't how much you study, but how you're studying? I mean, we've all been there, haven't we? Pulling that all-nighter before a huge exam, running on nothing but coffee and sheer willpower. You're highlighting everything, you're rereading your notes over and over, and you feel like you're really getting it. But then you sit down for the test, and it's like a thick fog rolls into your brain. The concepts are blurry, the formulas are just gone.
Okay, but here's the good news, and I really want you to hear this. It's not you. You're not bad at math or just not cut out for coding. The truth, and this is backed by decades of cognitive science, is that a lot of the most popular study techniques are, well, they're actually the least effective. You're putting in the hard work, but your effort is just being pointed in the wrong direction. So let's kick things off by talking about something that cognitive scientists call the illusion of learning. This is a big one. These are all those study habits that make you feel super productive, but in reality, they don't build any real, lasting knowledge. They just create this false confidence that, let's be honest, completely crumbles the second you're under pressure. Just look at the difference here. On one side, you've got the usual suspects, right? The comfort zone. Rereading your notes, highlighting half the book, cramming all night. These things are passive. They feel good because the material starts to look familiar. But here's the key. Familiarity is not the same as understanding. Then on the other side, you've got the stuff that actually works. Practice testing, self-explanation, space practice. And yeah, they feel harder. You know why? Because they are harder. And that effort, that struggle, is exactly what builds strong, solid memories. And hey, don't just take my word for it. Educator John Dunlawski puts it perfectly. These super common strategies are popular, for sure, but they just don't deliver when it comes to remembering things long term. So what does this all mean? It means we've got to replace these bad habits with ones that are actually backed by science. And to do that, we first need a little peek under the hood to see how our brains are wired to learn. And that brings us to a really essential idea from learning science called cognitive load. The best way to think about it is like this. It's basically the operating system for your brain. And if you can understand how it works, you've got the key to unlocking way more efficient studying. Okay, so your working memory, that's the part of your brain that's actively juggling information right now as you listen to me. It's kind of like the RAM in your computer. It's super powerful, but it's also very limited. It can only handle a few new things at a time. Cognitive load is just the fancy term for how much of that RAM you're using at any given moment. If you overload it, your system crashes and learning just stops. But if you manage it well, you can learn pretty much anything. But here's the thing. Not all cognitive load is created equal. There are 3 types. First, you've got intrinsic load. That's just how difficult the topic is, period. I mean, calculus is always going to be harder than basic addition. Can't change that. Then there's extraneous load. Think of this as the bad stuff, the mental junk food. It's all the effort you waste on a confusing textbook or studying in a noisy room or using useless methods like rereading. Our whole goal is to get this as low as possible, because that leaves us with germane load. And this, my friends, is the good stuff. This is the effort your brain spends actually connecting ideas, building real understanding, and forming those deep, long-term memories. So, the whole game is really simple when you think about it. We want to slash that useless, extraneous load so we have more mental horsepower for the good stuff, the germane load. See, smart studying isn't about being lazy or trying to find shortcuts. It's about being efficient. It's about channeling your precious mental energy into the things that actually build knowledge. And that is where the right techniques become absolute game changers. Okay, so how do we actually do that? How do we maximize that good germane load? Well, let's start with what is, without a doubt, the single most powerful tool in your entire study arsenal. Now, it's going to sound a little weird, but it's all about embracing the act of forgetting, and then forcing your brain to remember again. This is called retrieval practice. You might also know it as practice testing, and it's simple. Instead of passively looking at your notes, you put them away and you actively try to pull the information out of your head. Every single time you successfully retrieve something from memory, it's like doing a rep at the gym for that piece of information. You're not just remembering it, you're literally strengthening the neural pathway to it, making it easier to access next time. That struggle, that active pulling, that is the germane load we're talking about. It is a genuine workout for your brain.
And look, the evidence for this isn't just a little convincing, it is absolutely overwhelming. A huge meta-analysis looked at 744 different studies.
And get this,
Those studies involved a massive 222,708 students. And the conclusion? It's undeniable. Practice testing is one of the most powerful, most reliable, most well-documented learning strategies we have ever discovered. Seriously, if you only change one thing about how you study after watching this, please make it this one. But, of course, being a pro in STEM isn't just about memorizing a bunch of random facts, right? It's about seeing the bigger picture, understanding how all those facts connect. And for that, we need strategies that build a real web of knowledge in our minds. So let's talk about two fantastic techniques for this: self-explanation and cognitive mapping. Self-explanation is so simple but unbelievably powerful. All you do is pretend you have to teach a concept to someone else. Take something tricky, like recursion and coding, and try to explain it out loud to a friend, or even just your desk lamp. What this does is force you to connect the new stuff to what you already know, and it immediately shines a huge spotlight on the parts you don't really get. And then there's cognitive mapping, which is all about making your thinking visible. It helps you actually see the structure of a complex idea, like all the moving parts of a machine learning workflow. Now, there are two main ways to do this, and you can use anything from a simple pen and paper to some really cool digital tools. Concept maps are all about structure and hierarchy. You connect ideas with specific links, like causes this or is an example of. They're perfect for breaking down an existing system, like an algorithm or a complex biological cycle. Mind maps, on the other hand, are way more free-flowing. You start with one central idea and just branch out with whatever comes to mind. They're awesome for brainstorming or just exploring creative new ideas.
All right, so we've got these powerful techniques. Awesome. But now for the practical question. How should we actually structure our study time? We know cramming is out. It just completely overloads our working memory with all that junk, extraneous information. The real key is to work with our brain's natural rhythms, not against them.
And probably the most famous method for this is the Pomodoro technique. I'm sure you've heard of it. You just work in a super focused, no distractions sprint for about 25 minutes, and then you take a short 5-minute break. That's it. This little cycle is genius because it helps you manage your cognitive load and stops you from getting burned out. It makes sure your sharpest focus is dedicated to that good germane load, and the breaks give your working memory, your brain's RAM, a chance to cool down and reset.
And this whole idea of focused work is getting even smarter. This is where it gets really cool. Researchers are actually developing new tools. There's one called Colotima that use things like eye tracking to measure your cognitive load in real time. Just imagine that. The goal is to create systems that can dynamically adjust your study and break times to perfectly match what your brain can handle at that exact moment. We're talking about a truly personalized, super optimized learning experience.
All right, that was a lot of theory, I know. So let's make this super practical. Let's talk about your action plan. I'm going to give you a list of concrete steps you can take literally the second this is over to start putting all this science into practice. First up, test. Don't just read. After you finish a chapter, close the book and just scribble down everything you can remember. Second, explain it out loud. Find one complex idea from class and try to teach it to someone. Third, map it out. Grab a piece of paper and draw a concept map connecting the main ideas from your last lecture. Fourth, just do one Pomodoro. That's it. Just commit to 25 minutes of pure distraction-free focus today. Fifth, mix it up. This is a big one called interleaving. Instead of grinding through 20 calculus problems, do 5 from calc, then 5 from last week's physics, then 5 from chemistry. I know it feels harder, but it forces your brain to learn how to pick the right tool for the job, which is a critical skill for any exam. And finally, number 6, work backwards. You know those faded examples in textbooks where they show you the first few steps? Cover up the solution, try to solve the next step on your own, and then check. It's an amazing way to bridge the gap from seeing an example to solving a problem all by yourself. Listen, the payoff for making these small changes is absolutely enormous. This isn't just about bumping up your GPA. It's about reclaiming hundreds of hours of your life and building a much deeper, more intuitive understanding of your subject that will stick with you for your entire career. It's a true investment in yourself. So I'm going to leave you with this question. What is the one bad study habit you're going to replace today? Just one. You don't have to overhaul your entire life overnight. Just pick one thing and start there. Thanks for sticking with me on this one.